Hi everyone, please remember to take all notes. Feel free to pause the video at any point if you need more time to copy something. Today we're going to be talking about how to graph linear inequalities. So if we remember from the past, an inequality has a less than, greater than, less than or equal to, greater than or equal to symbol. One of those four rather than an equal sign. So here are the steps that we need in order to completely graph a linear inequality. The first one is to solve for y. And we know that's not always needed, so only if necessary. The second is to graph using what's called a boundary line, and we'll talk about what that means. And we know that requires us to make a table and label. The third is going to be after a decision you make on your own, whether or not you use a solid line or a dashed line. And the fourth is probably going to be the toughest point, which is when we shade. Okay, then I want to just give you one reminder. Don't forget about something we learned in the past, which is HOY and VUX. For those, no table is necessary. So we know how to solve for y, and we know how to graph and make a table of values and label. But step 3, deciding if we use a solid line or a dashed line, all depends on the inequality symbol we're given. It's very similar to when we graphed on a number line earlier in the year and we decided if it was an open circle or a filled-in circle. So for it to be a solid line, of course, we could do what we've been doing all along, which is with an equal sign. But it also works for less than or equal to or greater than or equal to. A dashed line is used for less than or greater than. Okay, here's our first example. Y is less than x plus 5. Okay, so shortly you're going to need to set up a set of axes and draw your x and y axis on your paper so that we can plot the points. Feel free to pause it if you need time to do that. But I'm going to start making my table of values. Now, notice here that we have a less than symbol. Okay, we don't have an equal sign. The boundary line is basically the line that's going to separate this graph into two different parts. It kind of makes a barrier between the two different parts of the graph. So when we make our table of values, it's almost like we're going to pretend that that's an equal sign and use the same values. Okay, the difference comes in when we decide if it's a solid line or a dashed line. Okay, so if you're trying to make your table of values, you could do it by hand by plugging -2 in for x, -1 in for x, and so on. Or you can use the equal sign in your calculator at the y equals button. Okay, so take a minute, fill in your table of values. Once you fill them in, go ahead and start plotting your points. But don't go any further than that. Once your 5 points are plotted, now we have to decide, is this going to be a solid line or a dashed line? Since it's a less than sign, we're going to make a dashed line. Okay, you can still use a ruler to do this, or any straight edge. Don't forget arrows. And we're going to label it y is less than x plus 5. Now, the last thing we have to do is shade. So, to determine shading, we're going to pick a test point. So you basically pick any point on your graph. However, I would not pick one that's on the boundary line. Okay? Pick any other point. So for instance, I'm going to say that mine is 4, 0. Okay, which is over here. What we're going to do is take the original inequality and plug in the corresponding values. So 0 is less than 4 plus 5. 0 is less than 9. Well, this is a true statement. So that means that we're going to shade on this side of the line. If we got a false statement, we know we would have to shade on the other side of the line. Okay, so you want to shade where the statement's true. This is called our solution set, and sometimes we'll put a letter S over our shading to indicate that. That means any point in that shaded region will satisfy this inequality and make it true. For instance, let's say we checked another point in our solution set. So let's say I pick 8, 2. Okay, that's in my shaded region. If I plug it in, I get 2 is less than 8 plus 5. 2 is less than 13, and it works. Okay, for our second example, we have x is greater than or equal to 2. So a couple things to note off the bat. There's no y in here, so we have to use VUX. So this might indicate that you don't necessarily need a table of values if you remember what it looks like. We also can tell that because of the symbol, we're going to have a solid line. VUX indicates that an x equals equation would be a vertical line. So we essentially know that the line is going to go through 2 on the x-axis and be vertical and a solid line just like that. Okay, so that's why I say the table of values isn't necessary. We can still fill it in though. So for instance, the x value for all of those points on that line are just going to be 2. And this is something that we can't even type into the calculator because it's not in a y equals format. The y values are going to be basically every integer value, assuming we're not using any decimals here. Okay, just to make nice, easy points to plot. Okay, so we need to now pick a test point. So I'm going to pick anything besides a point on the boundary line. So for instance, I'm going to pick the origin, 0, 0. So I'm going to take my inequality, x is greater than or equal to 2, plug it in, and I get 0 is greater than or equal to 2. That's false. So that means if you look at my picture, 0, 0 is to the left of our line. That means we need to shade on the right because the values will be true on the right. We can label that with an S, and we can check a point. So pick any point in our new shaded region. So say I pick, let's do 8, 0 again. It's 8 greater than or equal to 2. Yes, so we know we shaded the correct area. Okay, for our final example, I'm just going to start this one off for you and have you finish it. We notice that the inequality 4x minus y is greater than 2 is not in a y equals or y is greater than or equal to or y is less than or equal to and so on format. So we have to get y by itself and isolate it. So I'm going to do that towards the bottom where I have some more space. The first thing we have to do is move the 4x onto the other side. So we have negative y is greater than negative 4x plus 2. Remember, we don't ever want a negative y, we want positive y, so we have to divide by negative 1. When we do that, we have to remember a rule. When you divide or multiply by a negative, you need to flip the sign. So this is now going to become a less than symbol for x minus 2. So now here's our inequality that we can go ahead and make our table of values for. Okay, so I'm going to have you guys finish this one, fill in the corresponding y values, go through the remainder of the steps, be sure to shade at the end.